Section 3.5 is higher order derivatives. In this section, we talk about not just f prime of x, but what would happen if you took the derivative of the derivative. So what we've seen in the past, f prime of x is called the first derivative, or the first order derivative. So for example, let's say f of x is x cubed plus 5x squared. Then we know from the past that f prime of x is 3x squared plus 10x. But what if we were to take the derivative of this? Then the notation we use is f two dashes, f double prime of x, and the derivative of this would be 6x plus 10. Let's say we needed to take the derivative of this function. Then we would write the third derivative of 3 dashes, f triple prime of x, the third derivative would be 6. What about the next derivative? If you had to take the derivative of 6, the notation would be f, and now you'll see that these were actually Roman numerals. The fourth derivative of x is 0. So what would the next derivative be? Well, you can use 5 as in Roman, or you can use parentheses and put the number 5, and you'll notice that this trail goes cold. All the derivatives are 0 following this step from here on. Now something to think about is, will this always happen? Let's try, for example, g of x. How about the square root of x? To take its derivative, we first rewrite it as x to the half. First derivative is 1/2, x to the negative 1/2, half minus 1. Taking its second derivative, g double prime of x, this half comes along, then the negative half comes down, and x is raised to negative half minus 1, which is negative 3/2. If you were to clean this up, this is what you would have. And soon you're going to start thinking, alright, this one is not going to die out like this previous example did, and you would be right. So we're going to stop here though. Most of the applications in this class will stop at the second derivative. Okay, so f prime of x is the first derivative, f double prime of x is the second derivative. In your homework you might see a third derivative just for practice. We will do a worksheet shortly, but before I get to that, an application that I would like to explain here is, we had seen the concept of if distance is given by s, the distance function, then the first derivative was the velocity. Velocity was s prime, because s prime was the change in distance, okay, over time, how fast the distance was changing. Now think about driving on the road, okay, and you have your foot on your gas pedal, and that's how you move, okay, and that gives you the change in distance over change in time. Stepping on the gas and keeping your foot on the gas gives you velocity. But if you change your speed, what are you doing then? So what is change in velocity? Change in distance gave us s prime, so change in s prime is what I'm looking for, would be its derivative, so it would be s double prime. And what is it that you do when you step on your gas pedal to increase your speed? You accelerate. So this is acceleration. So that's what we're adding into our applications for this section, is acceleration is a second derivative of distance, or the derivative of velocity. So let's do some examples. This is the worksheet that should be on WebAssign. Determine the first and second derivatives of the function f of x, which is equal to all this. So f prime of x is, the 5 comes down, 10x to the 4th plus 12x to the 3rd minus 3x squared plus 2x minus 2. Hopefully you're able to do it as quickly as I just did. Just a little practice from the first part of this chapter. The second derivative, make sure you use proper notation. F double prime of x, the 4 comes down, 40x to the 3rd, 3 comes down, 36x squared minus 6x plus 2. So that was pretty straightforward. Things are about to change, so I'm going to clean out this worksheet, make sure we don't get mixed up here. First derivative, f prime of x. We see here that we have an outer function and an inner function. We need the chain rule for the first derivative. So the 5 comes down, x squared plus 7 gets raised to 4, times, you go inside, the derivative is 2x. Since we have an x here and a multiplication, in the next step we will need product rule. So before we do that, we should really clean up. These two are outside the parentheses, so you can combine them. 5 times 2x is 10x times x squared plus 7 to the 4th. So there's your multiplication for product rule. This is your first function, and this is your second function. Let's set up the product rule. F double prime of x. We need the derivative of the first, keep the second, plus keep the first times the derivative of the second. Okay, so derivative of the first, keep the second, plus keep the first, derivative of the second. Let's put it all in. Derivative of 10x is just 10. Copy the second as is. Take that off. Now keep 10x as it is. Now here the 4 comes down, and then x squared plus 7 gets raised to the 3rd power. We're doing chain rule. Then you go inside, derivative of that inside is 2x. So this takes a little practice. If you want to rewind and listen to the explanation again, you should do it. For the next example, right from the beginning, we have a product. We have a function 1 and a function 2. We need to use a product rule and chain rule for this piece. So f prime of x, derivative of the first, keep the second as it is, plus keep the first and the derivative of the second. So the derivative of the first is just 2x times the second, plus keep the first. The 4 comes down, 3x plus 2 gets cubed, times, you go inside and you get a 3. Before you move any further, you should clean up, or else it'll be a big mess. So here you cannot distribute all this because of the exponent. Just leave 2x as it is, 3x plus 2 to the 4th, plus over here, these are stray terms, all these. This part cannot be messed with because it has that exponent. 4 times 3 is 12 times x squared, 12x squared, times 3x plus 2, quantity cubed. Okay, so this plus this times this. We need to use a product rule twice and chain rule within. So f double prime of x. I'm going to cover up the second part. Let's not even look at it right now. Let's just do this part. The derivative of 2x is 2. Keep the second as is, plus, product rule has a plus in it. Keep the first. The derivative of the second, the 4 comes down, 3x plus 2 gets cubed, times, go inside, chain rule, get a 3. So we're done with this. I'm going to put a big plus. So I'm going to cover up the second piece. The first piece, and just look at the second piece. We need its derivative. The derivative of 12x squared is 24x. Keep the second as is, plus keep the first as it is, then bring the 3 down. 3x plus 2 gets squared, go inside, times 3. Now good news is you can stop here. You don't have to clean this up because you don't need a third derivative. Alright, the next question, we have a square root and stuff inside it. So we're going to first rewrite it as all of this stuff raised to the 1/2 power. F prime of x, chain rule, the half comes down. Don't mess with the inside yet. Raise it to half minus 1, times, you go inside and need to take the derivative. I'm going to have a typo right here. So let's see if we can think about what is wrong with what I have written. It's the half comes down, this thing raised to negative half, and this has to be multiplied with all of this, and this is the mistake. We need parentheses right there. For the next derivative, f double prime of x, we can take the derivative of this and then keep this as it is. We're using the product rule. So Bring this negative half down, it becomes negative 1/4, 3x squared minus 2x plus 5 raised to negative half minus 1, negative 3/2. Keep the second as it is, plus, now keep the first as it is, times the derivative of the second, which is just 6. Okay, hope that makes sense. And finally, an application. We have a distance function given right here. We need to find a general expression for the car's velocity at any time t, which means find s prime, so velocity, s prime, it's negative 3t squared plus 16t plus 20. Just power rule. Find the acceleration. Well, acceleration is a second derivative, so bring that down, negative 6t plus 16. And then part C says find the acceleration at 1 second, so plug in 1. S double prime at 1 is negative 6 times 1 plus 16, which is 10, and it's feet per second squared. And then S double prime at 2 2/3, so 2 2/3 is 3 times 2 is 6, plus 2 is 8, it's 8/3. Okay, so S double prime at 8/3 would be, plug it in here, negative 6 times 8/3 plus 16, which is negative 16 plus 16 is 0. When is the acceleration 0? When is the speed not changing? Ever use cruise control to drive? And that's what we're talking about here. Alright, this homework's a bit challenging. Be sure to give yourself time and let me know if you have questions.